Welcome to this presentation entitled Continuous Deployment to the Cloud. Thank you for picking this session, even though there are other very interesting ones. Let's get started. So before we go to the main topic, I'm going to say just a few words about myself. My name is Marcin Grzejszczak. I work for a company called Pivotal, and I'm a member of the Spring Cloud team. I'm working mostly on these three projects, so Sleuth, Contract, and Pipelines. 2 days ago, you could see me give a talk about contract. Today, I'm going to give a talk about pipelines. My Twitter handle is @Grzejszczak, and my blog is toomuchcoding.com. So let's get it started, because we have a lot of stuff to talk about, assuming that everything will work. Okay. So whenever you go to a conference or read a blog post about a new tool, new approach, new something, you should ask yourself a question. What problems are we trying to solve? Because if you don't have a problem, you shouldn't be using the tool, right? So with a continuous deployment or with Spring Cloud pipelines, what problems are we trying to solve? So this is the problem. The necessity to create a deployment pipeline from scratch for each new project. So, I mean, for sure, it's not like this at your companies, but whenever I change jobs or projects, it turned out that you have to create a pipeline. I mean, from scratch. You have a new tool, like you had Jenkins, now you have Bamboo or TeamCity, and you have to create the pipeline. So, yeah. So, what is Spring Cloud Pipelines? It's a GitHub project that contains an opinionated template of a deployment pipeline. Like if you're using Spring Boot, it's an opinionated framework. It has certain defaults that you can customize. Here you have something similar, but in terms of a deployment pipeline. It's based on good practices from different projects, so it's not like somebody woke up in the morning and said, this is how you should deploy software. We gather feedback from different production systems, and then we combined it into a deployment pipeline. Also, we believe in the infrastructure as code approach. For sure, there are some people here who still have to go to the automation server, some sort of CI server, and click the jobs around, and you click them today, tomorrow they're gone, or in the morning you click something, somebody changed it afterwards, it happens. So we believe in the infrastructure as code approach, so everything comes from the code. That's because if your automation server goes down, it's like burned somehow, or somebody accidentally removes some jobs. Since you store the setup of the server and the setup of the jobs in the code, you can get it back in no time. The automation server setup should be also automated. That's possible. If you're using Jenkins, you have to know a little bit of black magic to do it, but it's possible that you don't have to click all the credentials. It can be taken from a special file called init-groovy, for instance. If you're using Concourse, you have nothing to really automate because it's already automated. What is more, if you have gigantic deployment pipelines, you can write tests for those pipelines. And then you can refactor the code that builds your pipelines without being scared that you're going to do something wrong. So we support following automation servers out of the box. It's Concourse. Jenkins using Jenkins Job DSL. Who is familiar with Jenkins Job DSL? Okay, cool. And Jenkins using Jenkins file with Blue Ocean. Who knows the Jenkins file bit? Okay, a couple of people. So I'm going to show you that in a sec. The key thing is that logic of all steps in the pipeline is done in Bash, which means that to convert the way, for example, you deploy apps, you have to change just the Bash scripts. You don't have to touch the pipeline itself. But what's even cooler, you can use any automation server you want, because you just have to provide, like execute the Bash script and provide the environment variables. And that's it. We support Maven and Gradle out of the box, so if you're using a Maven wrapper or a Gradle wrapper, we will know how to build your stuff, assuming that you follow certain conventions that we require you to follow. This is how the pipeline looks with Concourse. So the green thing is a job. Job consists of tasks. You can't see anything, basically, because you would have to zoom it in. This is how you define a job in Concourse. So you have a YAML file, you have some name of the job, some inputs, some outputs, and some tasks that have to be executed, and you pass some properties over there. I'm not going to focus on Concourse today. I'm going to more focus on the Jenkins stuff because it's more widely used, but like at the end of the year, I should be giving a talk in Spring 1, hopefully, if I get accepted, with Concourse. So this is what we're going to focus on today. It's a deployment pipeline with Jenkins Job DSL plugin using the delivery pipeline view. So what we have here are stages: build, test, stage, and prod. Obviously, you go from left to right, but also inside a stage from top to bottom. So the green bar, of course, means that the job has passed. The red one will mean that something went wrong. This is how you define it. We're going to go into the code in a second, but in general, it's a groovy script that can be, like, you can embed the Jenkins Job DSL plugin into your project, and IntelliJ or IDE will help you write the code because it comes from a library, right? It's compiled. And now this is Jenkins file with Blue Ocean. Blue Ocean is the new UI from Jenkins, so it looks kind of nice. You go from left to right, and of course the green color means that everything went fine. This is how you define it. Basically, it looks kind of similar to Jenkins Job DSL, but the problem is that it's just text. You can have, I think it's called GDSL, that you can apply to your IDE, that where you have some definitions of syntax, but it's not compiled. So it's as if you were writing just text. I mean, some people like it, some people don't. The benefit for sure of this is that instead of creating for each pipeline like 15 jobs, you create one. So this is the main difference. Now, let's check out the code. So so this is the code of Spring Cloud Pipelines. I hope you can see it. So to the left, we have folders like Common, Concourse, Jenkins, and Tools. Let's check out Common. So in Common, you have bash scripts. Each bash script, for example, build and upload here, you can see, or prod and deploy, are one-to-one like logic of the step in the pipeline. So there has to be a step in the pipeline called deploy to production. And that's why we have this prod deploy script. But also we have a script called pipeline sh, where you have all the functions. So currently, for instance, in terms of deploying the app, we're using Cloud Foundry to deploy it. So at least in theory, or after I do a little bit of patching of Spring Cloud Pipelines, it will be enough for you to change just this function, and suddenly your whole pipeline will stop using Cloud Foundry, but will, for example, use Ansible or Kubernetes or something else, right? So the idea is that all the logic of deployment, of, let's say, building and running the apps is encapsulated inside bash functions. And let's check out, for example, production deploy. So as you can see, we're just executing functions. Those functions come from pipeline.sh. So we're retrieving some group and artifact ID. We're downloading the jar. This is the leaky abstraction because currently we have Cloud Foundry all over the place, but I will for sure abstract it away. So in here you would have something like login into a platform, for instance. And if you're using Ansible deployment, then your function login to platform would do nothing, basically, right? Because you don't have a platform. We're deploying some services. And for example, here we are doing A/B deployment. I'm going to explain this later on in the presentation, how exactly do we do it, but I wanted to show you like the idea behind the scripts. The next thing we have is Concourse. Over here we have just tasks and the pipeline. I'm not going to go into details of that. Once you clone the repo, you can check it out yourself. Let's go to Jenkins. So the first thing we have is the seed job. For those who are, it's heavily parameterized. So this is the Jenkins Job DSL bit. So what it does, it's essentially creating a job called Jenkins Pipeline Seed, from which other jobs will be generated. A seed job is a job that generates other jobs. By the way, I'm going to use the word job a lot today. So what it does, it's essentially executing two files that contain job definitions. One is Jenkins Pipeline sample something, and the other is the one that uses Jenkins file. So let's check out this one. If we go here, we'll see the Jenkins file. As you can see, for some reason, IntelliJ thinks it's a bash script, but it's not, obviously. I don't have any support from IDE, I can show you the production deployment stage. So it's this one. So you just define that you need some environment variables, and then you execute some shell. The key thing is here. This is the logic of production deployment. So neither inside Concourse nor Jenkins do we embed special code like related to production deployment. The whole logic is inside bash scripts. And let's check out the Jenkins pipeline sample. So this is the code that is used, is not using the Jenkins file approach, but this is standard Jenkins job DSL. So over here, you can see that IntelliJ knows that these are methods, right? So you have support from your IDE. And what we're doing here is, for example, we're setting up the stage called prod. We have a task deploy to prod. We are masking passwords. Here you can see that I'm cloning the repo from Git. And I'm executing shell. And here, the same thing. I need the pipeline.sh to have all the functions, and then I just execute prod deploy. And once it's done, I trigger another job, and I push a tag called prod something, for instance, right? Okay, now let's check out the Jenkins itself. Awesome. So we have the Jenkins pipeline seed. So once I executed the job, I got all the other jobs. So what you can do actually is, for example, go to your stash, find all the projects, pass them to your seed job, and for all of those projects, generate pipelines out of the box. Here I'm passing only two repositories, GitHub Analytics and GitHub Webhook, but you could like search for more. And the pipeline looks like this, right? So you've seen that already. The red one, it means that something went wrong. So what are we going to work with today? We have some sort of a demo app. We have GitHub. GitHub is emitting events, like issue created, or let's say, yeah, something like this. And GitHub Webhook is the app that listens to those hooks. They come via REST. And then it sends via messaging the message to GitHub Analytics. Very simple case. GitHub sends hooks, GitHub webhooks catches them, and messages are sent via IMQP. So we're going to focus mostly on this part. So before we go any further, we have to define some common terms, so we're on the same page. For me, build environment is an environment where building of the app takes place. Typically, it's a CI/CD tool worker. Test is an environment where we deploy the app, we test it, but the environment does not resemble production in any ways. Actually, in this environment, we talk only to stubs. No real interactions take place. Stage is an environment where you test your app, but it does resemble production. So most likely, you're going to do some end-to-end testing. You have to set up data. You have to obfuscate this data. So it takes, most likely it's shared. So you have to queue. You have to wait for your turn. And production, obviously, once we tested everything, we deploy the stuff over there. So now there's like a key question. Why do we deploy software? What's the point? So we're paid for delivering business value. I mean, some people forget about this, but only if we deploy our software to production, we are going to get paid. And features are done only when they are deployed to production. The business doesn't care about your test or stage. It makes no sense for them. Production is the only place that matters. And it's better to deploy frequently for faster feedback from two perspectives. Technical one, because it's easier to manage a small chunk of deployment rather than 1 year of changes that get deployed. But from the business perspective, it's even more important because the business can see faster the feedback from their business ideas, right? So instead of waiting for a year to see that none of the business ideas make sense, they can know this, for example, after a week, right? So they can take certain decisions. In terms of the deployment pipeline, from our perspective, it's better to fail fast, to fail as fast as possible. So if we have a typo in the API, we don't want to wait 4 hours until the end-to-end tests are finished. It would be best if I can fail on my laptop. You should do deployments in a standardized, automated fashion. Standardized because that way you can, let's say, move people around easier because they don't have to learn everything from scratch whenever they change projects. And cost of support is lower. And automation, if some people do something in a manual way, most likely they're going to make a mistake. And we don't want to make mistakes. Your deployment pipeline should test your possibility of doing a rollback. Who has a deployment pipeline that tests a rollback? Nobody? Okay, one person. Okay, good. Nice. Have you heard about GitLab? They had 5 ways of doing rollbacks, and none of them worked. So you should test it. If you test the possibility to do rollback, then you can do A/B or zero downtime deployment. I'm going to show you how. So let's focus on those 2, fast feedback. So we're focusing on the build stage. So the problem currently we have is slow feedback. You don't want to wait until the end of end-to-end test to see that something is wrong. End-to-end tests tend to take a lot of time. You want to fail fast even during the build time, especially in case of faulty integration. Or if our API changes are backward incompatible. So in order to check it, we should have it checked as soon as possible. So the solution, I mean, you're going to see a lot of Captain Obvious solutions. So if the problem is slow feedback, you should have a fast feedback, right? So how can we do it? First is unit integration tests, nothing special, you already do it. But you could consider using contract testing, for example, with Spring Cloud Contract, where we support HTTP and messaging. And how is it done? So on Wednesday, I gave a talk with Josh, which was 45 minutes about Spring Cloud Contract. Today, I'm going to give it to you in 5 slides. So if you don't, I mean, hopefully you're going to get the idea. So the producer defines a contract. A contract is an agreement between 2 sides on how we're going to communicate, either via REST or messaging. And now, if we want to really trust this contract, we have to test if actually what's written in the contract is true. So from the contract, we generate the test to see if the producer is not lying. If the producer says, I have a full endpoint and I'm going to return bar if you shoot a request there, we're going to test it because we don't trust anyone. And we're going to generate stubs from the contract because we want to speed things up. We don't want to start any apps for tests. And that way, the consumer can reuse the stubs without running the producer. So I can fail at build time if integration fails on my laptop. And since all stubs are put in a Nexus or Artifactory, so a single hosting place, they can be reused. So how does it look like? So let us assume that we have a contract on the producer side. Here you can see that we have a message contract related to messaging. So we say that there's some description. There is a label called issue created v2. And let's focus on this output message. So there is a destination, like a topic messages, to which we're going to send a message. And there's certain body, the payload of the message that we expect the producer to send. So now, body contains username and repository, right? Let's focus on this. So now what happens is we generate tests on the producer side where we actually trigger the message and we verify if a message on a destination called messages was received and if it contains the values that the producer declared that it's going to send. So body contains username and repository. So the consumer says, okay, this is what I expect, because this is what you told me, right? Username and repository. I'm going to run my tests. The tests pass. So what happens is, this is Spring Cloud Contract. Basically, we're downloading the stubs of the GitHub webhook, because at this point, the consumer is GitHub Analytics. So I'm downloading the stubs of GitHub webhook, and I'm triggering a message from the stubs. So over here, I say that initially I had 0 issues. I triggered the message, so I should have 1. And the test passes. Cool. So now, GitHub webhook decided to break the contract. So it changes from username and repository to user and repo. It's a breaking change because the field is changed, right? So the tests are regenerated. The producer made them pass, so changed the whole implementation. The stubs got installed, right? So or they get published somewhere to some hosting place. And now, when the consumer, so GitHub Analytics, runs the test on the laptop, what happens is it fails because expected fields are repository and username, but in the stub, I got repo and user. So without the need to start the other app, to send a message, I can get it like immediately on my laptop with almost no CPU usage. So we fail fast. Faulty integration, I can fail on my laptop. Now, let's say that we want to break the compatibility of the API. So we have another contract where we define that I have a URL issues with a delete method. If you shoot it, I'm going to respond with 200. A very simple case. So this is the first scenario. So we have a like v1 of the jar with the delete at issues and contracts that define the same thing, right? So I have an implementation of this, and I have defined it in the contract. So now with v2, I'm doing a backward incompatible change, which means that in the jar, I'm removing the endpoint, and I'm removing the value from the contract. Removing an endpoint is a backward incompatible change, right? So now, what I want from the pipeline is to do this. This is my implementation that I want to deploy to production. I remove there the delete endpoint, but I want to test against the latest production deployment that contains the contract, if that's still the case. But obviously, it's not, because I removed the endpoint. So auto-generated tests will try to send the request to the delete endpoint that doesn't exist anymore. So it looks like this. This is the patch where I deleted the mapping and I deleted the contract. When I go through the deployment pipeline, I get the failure over here. And that's because this test got generated, which says, I'm going to send you a request to the delete endpoint / issues, and I expect 200. But what I'm going to get is expected 200, but it was 405 or 404, something like this. So it comes from the pipeline. If you're breaking your contract, if you're breaking the compatibility, you will not go to production. That's it. You can do it like in a backward compatible way, but I'm not going to talk about this today. So this is how you can fail fast. Any typos will be caught. Any problems with faulty integration will be caught on your laptop. You don't have to wait 5 hours until end-to-end tests are finished. Now, standardization and automation and rolling back. So let's focus on the test stage. If you standardize a lot of your approaches, you will lower the support costs because you're doing stuff in a similar way, and you can have more chances to rotate people because they will not need almost no time to let's say get into the project, right? So in our case, we suggest that you use some sort of a platform and special tooling to automate some stuff. You can use platform as a service to standardize the way you deploy and monitor your software, right? By default, at the moment, we're using Cloud Foundry as a platform as a service implementation. I will add Kubernetes as well to Spring Cloud Pipelines for sure. For the demo, if you clone the project, you can use, for example, PCF dev, so development versions of Pivotal Cloud Foundry, which you can run on your machine. Remember, you need to have, remember to watch out for your laptops, and remember that if you run this, you need a lot of RAM, Actually, for this presentation, I've managed to push everything to the cloud and Amazon because it would be scary to run this demo during a presentation. So why could you consider using Cloud Foundry or any sort of platform? Because it abstracts the way you govern your app from the infrastructure, which means that regardless of whether you're running your app on your laptop or Amazon, Google, Azure, you deploy and monitor the software in the same way. It doesn't matter where you run. Another thing that you can automate or standardize is the way you upgrade your DB schema. In our case, we're using tools like Flyway or Liquibase. In the demo, it's going to be Flyway. If you don't know it, you're going to know it in a second. This is how you deploy software with Cloud Foundry. You do CF push, and the platform knows how to run your stuff. As simple as that. So now the demo. Hopefully it's going to work. If not, I have slides with screenshots. So this is the Cloud Foundry. This is Pivotal Web Services, so it's Cloud Foundry running on Amazon. You have organization and spaces where you can, let's say, logically separate how you run your apps. And here you can see 3 spaces: pipelines, test, stage, and prod. So I have a space for each of the stages, right? So right now we are in prod, and I have a couple of apps running. So it's Analytics, Eureka, Webhook. So I can immediately see the apps that are running. I know the instances. I can see what services I have here. So I have Rabbit. I have MySQL. So let's check out GitHub Analytics. So if we go here, this is a better idea. So if we go here, we will see the list of events that occurred for the GitHub Analytics app. We can increase the number of instances. I'm not going to do it because the demo will not work for sure. I can increase or decrease the memory usage, the disk. I can do it both from the UI. I can do it from the CLI. I can stop the app. I can restart it without any problems. I can see what services are bound to it. The cool thing is I'm using MySQL and Rabbit, and I don't need to provide the credentials myself. They're going to be injected by the platform to my code, because the platform knows Spring apps. It sees that there's Spring, and it says, OK, so you're using Rabbit, so I'm going to inject the password and username, or like MySQL. I'm going to inject everything for you. You don't have to even know them, which is kind of cool in terms of security, isn't it? And we can see the route, so it's deployed to GitHub Analytics, SC pipeline, CF apps IO. So this is essentially how Cloud Foundry looks like. And you can run it on your laptop. So I'm going to skip those because it worked. This is the example of Flyway. So you provide just a SQL script where you create some tables or alter some stuff. And whenever the app is booted, this SQL is applied to your schema. So you don't have to do it manually. So now some conventions in the code before we continue. I have a Gradle app here. Who uses Gradle? Gradle users? Not many, but don't worry. Like the idea, like with Maven, it's a very same idea. I guess it's simpler to show it with Gradle. So we have a Gradle app, and in build Gradle, I define that please apply some setup from Gradle pipeline.gradle. So we have certain assumptions that your application should consider. For example, we have certain tasks that are required. In Maven, these are not tasks, these are profiles that you should implement. So we expect that you have a test, obviously, but you have a task called smoke to run smoke tests. You have a task called API compatibility to run API compatibility check. And to end for the same. Deploy, because in Gradle you can deploy artifacts in a lot of ways. None of them works fine. So you can pick which one you want. Here we picked the publish plugin, but you can choose something else, right? So we abstracted a concrete plugin by a task called deploy. And you need to tell us what your group ID is, artifact ID, what is the current version. There's a bunch of stuff that you have to have your project implement. That way, the pipeline will take care of the rest, right? You don't have to do anything with the code in the pipeline. Okay. So the test stage. We have two tasks, deploy to test and tests on test. So what happens is we deploy the app, and what happens is that we upgrade the database schema because we were using the tool like Flyway. We ran a handful of smoke tests, a handful. Because the QA department tend to write bazillion of tests for every single feature, especially UI tests, even though it makes no sense. So here, explicitly, smoke tests. If your app has, let's say, 10 features, 2 of them are crucial, test those 2. Because the rest you have tested in unit and integration tests. Why? Because we want to just test that the app is properly packaged, right? And here we surround the app by stubs, no real integrations take place. And if you've seen my Spring Cloud Contract talk, you're already familiar with StubRunner boot, so there's a StubRunner boot app there as well. It's an app that serves stubs, right? So your application in the property says, I need those stubs. We take it out and pass it to StubRunner. The stubs get downloaded, and you don't even know that you're talking to stubs. Or you get messages from stubs. Rolling back DB. We should have in the deployment pipeline some sort of a way to check if we can roll back. But rolling back database changes is extremely difficult, especially if you're doing deployments each 6 months. You have so many changes that it's close to impossible to roll it back. Also, how can you roll back a deletion of a column? You would have to force it somehow so people don't do it, which is a valid thing to do. So let's focus on those 2 subsequent steps. So what we are doing is we're not doing a database rollback. I told you, Captain Obvious solutions. If something is difficult, don't do it, right? So what let's say, can I propose in return? Let's always do backward compatible changes, fair enough. You could do it still, let's say, without using all of the stuff that I'm talking about. Or you can perform backward incompatible changes in a backward compatible way. You can check out my blog post called Zero Downtime Deployment with the Database at Spring.io blog. But what happens is that we want to roll back the jar only, the application, not the database. Which means that if you can test it, we can be sure that the database changes are backward compatible, right? So what we're doing is we're searching for the latest production deployment, and we're testing it against the changed version of the database schema. I'm going to show you that on slides like in a second. The key thing from this is if we can ensure that we can run the current version and the old version simultaneously on the changed database, it means that we can run two versions of the app at the same time, which means that we can do zero downtime deployment and A/B testing. So let us assume that we have version 1 of the jar, and the repository, that is the name of the column, repository. And in the database, in the schema, we'll have also repository. We're introducing a backward incompatible change, so we're changing repository to repo, and in the database schema, we're also doing repo. So what we're going to do is we're going to download the code of the V1, which went to production, and we're going to run it against the change database schema. Obviously, we expect this to, blow up, because it can't work. So how does it look like? We have the first script where we define ID, username, and repository. It looks like this, the schema looks like this, ID, repository, username. Then we apply the change, alter table issues, change repository to repo. Boom, now we have a repo. So this is the first flow. We went to production with version from 14th of June. So it's V1. And now if we introduce the backward incompatible change, over here we're downloading the V1, so from June, and it's going to fail. And how it's going to fail? If you take a look at the logs, you'll see that the old jar is trying to, let's say, insert data to a column repository that doesn't exist. So if you have it in your deployment pipeline, you can ensure that none of these things will happen. Okay, stage. Time for controversy, because I have a problem with end-to-end tests. I have a big problem with end-to-end tests. It takes ages to run them. They are slow and brittle. I heard from a QA department, from a guy who was leading a QA department, saying that they are paid to write tests. So it makes kind of no sense. I'm telling him, it makes no sense to write, we don't gain any money from this feature. Why do you have a UI test for this? Because I'm paid to do it. I mean, fair enough. Another problem, how will you set up tests? How do you set up environment for the end-to-end tests? If you have microservices, let's say 50 of them, will you have one environment shared between all applications and end-to-end tests run, for example, for 2 hours, so you have to wait, I don't know, hundreds of hours for your turn because you're in the queue? Or will you have one environment per application? So you're going to have 50 stage environments. Who's going to pay for that, right? Still, let's say that we have a lot of money. So will you surround your apps in production versions or development versions or both, right? Do you have a separate team that does obfuscation projects? So a project that, you have to obfuscate all the data because it's not enough to generate data. Sometimes you have to have logically proper data over there. So sometimes you have, 5 or 10 people just doing this, right? It's very complex. So maybe let's not do it if it's problematic, right? The thing is, regardless of the time you spend on QA or UATs, you can still have bugs because stage is not prod. So let us assume that. You embrace failure, that we accept that things can go wrong. We introduce monitoring of our business key performance indicators. In our case, it's the number of issues that we got. Let us assume that if we go below 4 issues, it means that our system is broken. And if we introduce alerting over those metrics, then we know that we can roll back on production because we went through the whole pipeline, right? So we know that we are backward compatible. Then actually you can stop doing any end-to-end tests. But let's say I'm suggesting you think about this, but some people might think I'm crazy. So you can still have stage. The whole step is optional. By default, it's turned on. And these both steps are manual because you have to wait for your turn to run for the environment, as I mentioned. Typically, you have one stage. And you have to do some manual work, purge data, I don't know, prepare some external apps, whatever, right? Okay, so A/B and zero downtime deployment. So the last step. Some people have problem with deployment to production because we have to do it at night, for instance. Everybody loves doing deployments at night, right? Especially there's nobody there to test it, right? So you do it at night. You click around. I mean, you're half awake, so it seems that everything's okay. You go to sleep for 3 more hours because the first shift arrives, and they tell you nothing works, right? So that kind of sucks. We would love to treat a production deployment like any other deployment. We shouldn't be celebrating like champagne. Oh, we've made the first deployment within a year. You should be doing that automatically. You should even forget about the fact that we're doing deployments. And we'd like to do A/B testing as your downtime because that way we will be less scared, right? Because we always have the old instance that is working. So we would like easily to roll back if something goes wrong. So the solution might be Cloud Foundry or a platform plus Spring Cloud pipelines. So in this case, we have our KPI monitoring in place, and we have set the alerts over those KPIs. We went through the pipeline, so we know that we can roll back the app. And Cloud Foundry can take care of zero downtime deployment. How is it done? You're going to see that in a sec. So when we click deploy to prod, this step can be either manual or automatic. I suggest it's automatic. So what we do is we deploy the app next to the old instance. So there's the old instance. We deploy, let's say, the new one next to it. And then you have this moment where you're checking if everything works fine. And then you have this manual step called complete switchover, so you can delete the old one and leave only the new one. And we tag the version with prod/version because we need it for the previous steps, right? For the API check and the database check. So, how does it look like? This is the old instance. I don't know if you can see that. Maybe I can. Oh, no, I can't. Never mind. So I'm going to read it to you. Here you can see GitHub Analytics Venerable, which means this is the old instance. So what happens is, when you deploy the new instance, we rename the GitHub Analytics to GitHub Analytics Venerable, so it has a different name. We deploy the new instance with a GitHub Analytics name, but what is important is that both apps are bound to the same hostname, right? So we have 2 instances, old and new one, with 2 different names running under the same hostname. So Cloud Foundry does load balancing. So if you want 10% of traffic to go to the new one and 90% to the old one, you can scale the old version instances to 9, for example. And that way, you'll have 90% of traffic over there. And once you're done, you click complete switchover, and only one app remains. The other one is deleted. And the pipeline does it for you, right? You just click on the deploy to prod and complete switchover. So now alerting, because this is crucial. If you don't have alerting and metrics, just don't do it. Do stuff what you did until now, because without this, you don't know that something is wrong. So we have GitHub webhook. It receives a post message and sends a AMQP message to GitHub Analytics. And we have Prometheus, which is an app that basically, let's say, scans your apps for metrics, with Grafana, which is the UI over Prometheus in this case. What we're going to do is I'm going to curl some requests. You're going to see a number of issues going up. And then I'm going to shoot at this endpoint that every application has, which is delete. I'm going to delete all issues. Prometheus with Grafana are going to pull it. And in Grafana, I have provided the alert for the value of issues. And it's going to push a notification to Slack with a grumpy cat saying that something is wrong. OK, hopefully it's going to work. Let me open Slack. OK, so this is our app. We have a couple of issues. OK, There are some issues. Let's go to Grafana. We have number of issues is 8. Okay. So let me add some more issues. Scripts. So I'm curling the GitHub webhook, and it's sending a AMQP message to GitHub Analytics. Let me curl twice. Okay. Okay. So we have more issues. How many? I can't see it. 10. Okay, makes sense. So now, what I'm going to do, here's my Slack. There's a lot of grumpy cats over here. Let me increase the font here. What I'm going to do right now, I'm going to curl the delete endpoint. Boom. And what happens is, suddenly we go down, and suddenly I get the message on Slack. What's wrong? And I see the number of issues is 0. So I immediately know that after I deploy my app, even though the tests have passed, everything seems fine, suddenly I have 0 issues. What's wrong, right? So what I can do, I can go to Cloud Foundry and click stop on the new instance, saying, oh, okay, something's wrong. Or I can do it from the command line, obviously. I'm still working on having this also embedded in the pipeline that you can click it from there, but it's not that easy. So now, what I'm going to do is I'm going to curl some issues again. 1, 2, 3, 4, and 5. So if we go to Grafana, we're back again, and I have an alert that, hey, everything's fine. Of course, it's a very stupid, simple example, but it shows you an idea that if you want to do continuous deployment, you have to have such mechanism. If you don't want to do end-to-end tests, you need to have those mechanisms because you need to know that something is wrong. And if you're not doing either of those, still you should consider having metrics, right? Makes sense. So these are the slides if something went wrong in the presentation. Fair enough. So this is the whole pipeline. It looks like this. So how can you profit from Spring Cloud pipelines? You go to GitHub, you go to releases, and you download the source. You can fork it, but it makes little sense in my opinion. So or just curl it. So you use curl, you unzip it, you create a new project, and you have to modify the pipeline to suit your needs. I mean, companies differ between each other so much that it's difficult to, provide some sort of a customization out of the box. But there's a very important issue, 55, in Spring Cloud pipelines. So if you are interested in Spring Cloud pipelines, you start using the project, please note down the steps you took to make it adapted for your company and put it there in the issue. Because if more people do the same work, I will be able to provide some sort of a CLI or whatever for you to just make it run out of the box. So please provide feedback because, I can think of how you can automate stuff, but I prefer you to give me feedback. Summary. Continuous deployment allows you to continuously deliver business value. And this is the key thing that gives us our wages. Spring Cloud Pipelines gives you out-of-the-box tooling to test your software via different ways, like unit and integration tests, contract tests, rollback tests. And with Spring Cloud Pipelines, you can adjust the pipeline to suit your company's needs pretty fast. It's just a matter of changing bash. And if you're using Cloud Foundry or a platform, you can easily do A/B or zero downtime deployment. So I guess now will be time for questions. I can leave this slide. So there are here you can find all the links to both applications and analytics and webhooks. This is the documentation of Spring Cloud Pipelines. These are 2 trolley articles about no end-to-end tests. You can check them out. Here you can see some Cloud Foundry-related technical stuff. If you're interested in checking out Cloud Foundry, you can check out Pivotal Web Services. You get some, let's say, initial time for free, from what I remember. And if you want to check it out on your laptop, go ahead and download it. And yeah, you can read the docs. I'm also on Gitter, on the chat. So if you go to Gitter IM, Spring Cloud Pipelines, I'm there. I try not to sleep, answer your questions, so do it. And that's it. So time for questions. We have 5 minutes. Any questions? I guess not. So if you're shy, okay, go ahead. So the question was, when we're doing the A/B deployment, we have the old one and the new one, and let's say we scale the new one to like 9 instances, and the old one is 1, so 90% of traffic goes to the new one. Who's deciding? The platform, because the platform does load balancing, because you shoot your request at a URL that is shared between those 2 instances or 2 apps, so you have the same host name, so the platform decides how to change the host name to the proper instance. So it's the platform in Cloud Foundry, because you could do like some in-house thing that would decide like instead of the platform. But in case of Cloud Foundry, it looks like this. Go ahead. Yeah. Oh, it's not a question. You were like exercising. Okay. Yeah, go ahead. Kubernetes first. So the question is something else than Cloud Foundry. For instance, Kubernetes, for instance, Ansible, but for the deployment, right? Because it automates deployment, you would have to have something on the server to get, control of the instances, starting them and stopping. Because the platform as Cloud Foundry, or from what I know, Kubernetes, it takes care of the fact that when your app dies, it's trying to restart it. So you need to have some sort of a tooling like this. But if you have if you don't need such extensive platform let's say usage, for example, Ansible would be the choice. So I've shown you in the script, I'm going to show you this again, once I finish this task, obviously. It would look like this if we go to the prod deployment. You have login to Cloud Foundry. So I will make login to platform, because it can be either Cloud Foundry or Kubernetes. And if you, for example, consider using Ansible, you would implement this method and it would do nothing, right? Because from your perspective, you're interested only in, for example, deployment or setting up some services, right? So that would be the answer to this question. Any more questions? No more questions, so thank you very much, and yeah, enjoy the conference.